about how a IR sensor as well as how an ultrasonic sensor works. Here in this IoT lab experiment, we have combined both ultrasonic sensor as well as IR sensor with the Arduino processor, and these two sensors are going to collect some data. Okay, so this ultrasonic sensor, it is actually used to find the distance. So suppose if I am coming like this, when it comes near the ultrasonic sensor, so we have given a threshold distance. When this distance is detected, this sensor will give an output. So that output is displayed in terms of LED as well as buzzer. LED is glowing as well as buzzer is giving sound when the obstacle is getting nearby. So this ultrasonic sensor, it will be having one sender and one receiver. So this will send a signal, and the signal received by this receiver will be counted. That is, a pulse will be counted. So please you can see, go through the program. In this program, the ultrasonic pulse will be counted using the command pulse in echo pin. Okay, so this pulse in command is used to find the duration, that is the distance between the obstacle as well as the sensor will be identified using this command pulse in. Then for IR sensor, here we are using how to read this IR sensor is we are using the command digital read. That is, this IR sensor is actually a digital sensor. For both the sensors, we have to give supply voltage. The supply voltage will be obtained from Arduino board. So each and every sensor will be connected to the Arduino processor VCC as well as to the ground to give supply to these two sensors. Then this IR sensor can be used to detect motion. So when a person moves near it, one count will be checked. So when it moves away, that count won't be incremented. So this IR sensor is, this also works similar to this sensor. Here also some light will be used to detect the movement. Okay. So now 1, 2, 3. Likewise, we can use this sensor to count the number of persons entering a room or the number of cars crossing a particular point. Like that we can find. So this IR sensor is generally used to detect motion or to count some events. Generally it is used to count some events. And in the IoT lab, we have to collect the sensor value, and this sensor value could be uploaded to the cloud server for further analysis. So automation is the main purpose of IoT lab, Internet of Things, and these sensors are used to collect certain values, and based on this value we have to detect what is happening and we have to automate the process. Here we have just given alarm signal, and this alarm signal given to this these two output devices, LED as well as this buzzer, can be used to activate a relay or anything to automate the process. That is, if for example, if you want to allow only 30 members into the room, then after the count exceeds 30, we can make this output to close a room or like that. So for that we have to use a relay. So that's the purpose of this these two sensors.
Hello everyone, we are going to do an experiment on Arduino board with ultrasonic and IR sensor. Let's see the connections and the wirings for the Arduino board. After that we can see the field. First we have IR sensor and one ultrasonic sensor and one LED light for output, one buzzer for output, and there is Arduino Uno board and the breadboard for making connections and some jumper wires. Let's move on to the connection part of the Arduino. First we connect the ultrasonic to the breadboard. After that we connect IR to the breadboard. First we take a jumper wire. We take two jumper wires and connect one with VCC of 5 volts. VCC of 5 volts. And another with the ground. Connect these both to with this here in the breadboard, which will get connection to this whole column. Next we will connect the ground of the ultrasonic. Let's also connect the light here and here. First we connect ground of the VCC, ground of the ultrasonic with the ground. Yeah, let's do this here. There's a VCC. This is the ground. Second one is echo. Third one is trigger. Fourth one is VCC. So first we connect ultrasonic ground with ground and the VCC for another connection. VCC with VCC. The last one is VCC. So VCC with VCC. We connected both positive and negative terminals. Let's move on to the IR. For IR, let's connect. For IR, the second one is ground and the third one is VCC. So the second one we connected it with the ground, yeah, here, and the third one we connected it with VCC. Yeah, we finished our connection, and let's connect the ground of the LED with the ground. The short end will be the ground, so short end with the ground. We connected the power connection to the Arduino breadboard. After that, we have to connect trigger pin of the echo to the 9th pin of the Arduino. The trigger pin is second one, first, second. We connected it with the Arduino's 9th pin. The 9th pin is 8, 9. We can connect it like that. And we have to connect the echo pin with the 10th one. So the third one is the echo pin. Yeah, we connected it.
Where is the third one?
Yeah, connected it and connect it with the 10th. 8, 9, 10. Yeah. After that, we have to connect the ultrasonic wires connection are being completed. Next, we have to go to the IR connections. IR, there is only one connection, which is output. We have to connect the output. We have to connect the output with the pin number 8. It's connected with 8. Yeah. Once again, I'm reconnecting. This is the positive VCC. Yeah, finished it. Now both of the ultrasonic and IR connections have been completed. Next, let's move on to the LED connections. For LED, there is only one connection. We have to connect the positive terminal of the VCC LED to pin number 13. Usually the pin number 13 we use for output. So we are using 8, 9, 10, 8, 9, 10, 11, 12, 13. This is the 13th one. We just connecting it with the 13th. With this, the connection has been established. Let's check whether the connection is perfect or not. Yeah.
Here is the code. So these are the definitions. So we are defining macros. Here is the trigger pin, which will be used for the ultrasonic sensor, and the echo pin. Then here IR sensor pin, which is 8. LED pin is 13. Then we have an IR counter, which will be used to count the number of objects which are being detected by the IR sensor. For example, in a real-time scenario, you can find out how many students are entering into a classroom, and how many are getting out of the classroom. So you can identify that how many students are staying inside the room, or is there no one staying inside the room. So you can manipulate this kind of thing in real-time scenarios. And this is the variable for calculating the distance of an object using the ultrasonic sensor, which is duration and distance. So this is the setup function, and in setup function we will be initializing the serial monitor with a value of 9600 baud rate, and this is the pin mode LED pin output, and then pin mode trigger pin output. So these are output pins, and echo pin is input pin. Pin mode is also an input pin. So for IR sensor, we will also have an input pin. Then after doing the setup function, and this is a flag which will be used. I will show how we will be using that flag. So these are actually digital write. So for the trigger pin, read the distance from ultrasonic. So to read the distance, we initiate a trigger. So with 2 milliseconds delay, the trigger pin is low, and then we send a high signal, and we have a 10 microsecond, sorry, it's a microsecond delay. Then we try to capture the sent pulse. So the time between sent and received is stored inside the echo pin. So using pulsing, you can find the duration, how much time did it take to go and hit the object and come back. So that duration will be stored in this variable, and you can find the distance by using this formula 0.034 divided by 2, which is multiplied with duration to calculate the distance in centimeters. So now we will have the distance in centimeters. Now we are reading the IR sensor. So digital read IR sensor pin. So in the IR sensor pin, it gives you the output. So you will have the output. If an object is detected, then the value will be 0. If the object is not detected, then the value will be 1. So IR status will be stored in the IR variable. So if the IR variable is low, then which means the light should glow, because when it is low means it will glow, and when the distance is smaller than 15. What is the distance? This is the distance of the ultrasonic distance calculated from the ultrasonic sensor's input. So here you can see that when this condition, either this or this, is satisfied, then the LED is high, is turned on. Then if distance is lesser than 15, we will be printing this warning. So object detected within 15 centimeter. Then we were also talking about the flag. So the flag was initially set to 1. So if the flag is 1 and the IR status is low, which means this is the first time the IR has been low. So IR counter will be increased. Object detected by IR sensor count. So the count will be also printed now. Then flag is set to 0. Now this loop will be continuously running for every 500 millisecond delay. 500 milliseconds, which is like delay. So for every half a second, there will be a delay. So there will be a delay. So for every half a second, this loop will be running, and for every half a second, you will be getting the distance from the ultrasonic sensor, and you will be also getting the inputs from the IR sensor. So you will be getting the IR status, and so continuously when the IR status is low, the flag will be 0. It is set to be 0 after once. The second time it will come, the flag will be 0, and so that this function will not run. I mean, this if body of this if loop will not run, so the count will not be done, and this won't be printed. Then if this thing, so if the status is high or the distance is greater than 15, then we will turn off the LED, and flag will be set to 1, and that's it. This is the delay. That's it. So let's try to run. I'll show you. Show the output in serial monitor. Let's clear the serial monitor. So when I bring my hand closer, now you can see the output in serial monitor, that the object is detected within 15 centimeters. My hand is so the distance between the ultrasonic sensor and my hand is less than 15. So the light is also burning. The light is high and the distance is low, and we are getting out in the serial monitor. And now when we let's test the IR sensor. My hand is in, so now the count is 1. You can see object detected by IR 1. Now next second time, the count is 2, 3, 4, again 5. So that's how it is done. So hope you guys could understand the program, and that's it. Thank you.